Okay, let's do another example. Here we have a study of 420,098 cell phone users. 108 of them developed cancer of the brain or nervous system. Test the claim of a somewhat common belief that such cancers are affected by cell phone use. That is, test the claim that cell phone users develop cancer of the brain or nervous system at a rate different from the rate of 0.0340% for people who do not use cell phones. So for people who don't use cell phones, this percent of them get cancer. And so if this proportion is bigger than this proportion, that means that cell phones are contributing to cancer. We're going to use a 0.001. Oh my, that almost has to be a typo. Is it? No, it's not. Okay, 0.001 significance level. Identify the null alternate test statistic, p-value, conclusion, and all of that good stuff. So this time I'm not going to actually be able to figure out the critical value because it's off of my table. So we'll not worry about the critical value for this one, and we'll only rely on the p-value. So here we go. Null hypothesis, alternate hypothesis. This time, the null hypothesis is that p is equal to 0.00034. And the reason it's 0.00034 is because this actually has a percent behind it. So you have to move the decimal 2 spaces to the left. So it's 0.00034. P equaling that will be our null hypothesis. The alternate hypothesis is going to be that P is not equal to this amount. Now that sometimes gets a little tricky. I could understand if you put greater than for this, but for some reason they decided that this one was just a not equal to one, so we'll just go with that. Luckily, I think you get several chances. Remember that not equal to is our default. Okay, our formula is the same as it has been for the last couple. P hat minus P divided by the square root of PQ over N. So let's find our values. These numbers are going to be a little bit tricky, but that's okay. So P hat is 0.00034. P, oh, I'm sorry, that's incorrect. That's what P is equal to. I'm sorry. I got a little ahead of myself. P is equal to 0.00034. And to find Q, I'm going to have to do my calculator. So 1 minus 0.00034 is 0.99966. Okay, there we go. N is an enormous 420,098. And to find P hat, we do 108 divided by 420,098. 108 divided by 420,098, which is 0.000257. So 0.000257, is that different enough from 0.00034 that we get a result? So let's go ahead and calculate our test statistic. I'm not going to rewrite all of this, but I am going to do it in my calculator. So it's going to be 0.000257 minus 0.00034, enter, divided by the square root of 0.00034 times 0.99966 divided by 420,098. And we get the correct answer. If you round that to 2 decimal places, the test statistic is negative 2.92. Okay, so there you go. That's how you do this. If you have a question on it, please let me know. Now let's find the p-value by using that website again. So here we go. I'm going to use the back button to go back to the calculator. This time our null hypothesis is always equal to. Alternate hypothesis is not equal to. This time, I wonder if this calculator can even handle this. It's going to be 0.00034 was the hypothesis test number, the null hypothesis. This one was the number of samples sizes was 420,098. Number of successful cases, 108. I say successful, obviously it's not successful if you get cancer, but I mean the number of people who have the disease is 108. And our significance level is 0.0001, which is a super, super significance level. I mean, you have less than a 0.0001 chance of getting the results by chance. So we'll let the computer think for a second. These numbers are so extreme, I wouldn't be surprised if the calculator doesn't work. We'll find out though. Come on. Everybody needs to get off Netflix and YouTube so that we can do our statistics homework. You can see up here that it's thinking. If for some reason this calculator doesn't work for you, please let me know and we'll try to figure out something that will work for you. I wonder if it's hung. Feel free to skip ahead to where I actually have the answer. I'll have to wait though. Okay, I'm going to go ahead and stop the video here and start the video again when I get an answer. So I'll see you when this is done thinking.